This is Grand Admiral Rosine, following the physics directive to explain conceptual modern physics. It is finally time to answer the question, is the universe truly random? Quantum physics is known for its strange and confusing principles, yet superposition may be the most important among them. To understand it, remember the Heisenberg uncertainty principle. It is impossible to measure the exact state of an object, since the more accurately you measure one property, the less accurately you must measure another. If you wish to dive deeper into it, check out the video I linked in the description. Now, uncertainty makes it impossible to determine the exact state of the universe at any time, preventing you from making any exact predictions about its future states. But if it is impossible to predict how the universe will behave deterministically, why should we assume the universe is deterministic at all? And if it is impossible to measure the state of a particle exactly, why should we assume that it truly has an exact state at all? To explore this, we will consider a thought experiment known as Schrödinger's cat. Say that you put a cat in a box with a vial of poison gas. The vial is connected to a Geiger counter that will shatter the glass upon detecting radioactivity, releasing the poison and almost instantly killing the cat. There is also an unstable atom inside of the box. Because the atom's properties are unknown, we can only determine that after 1 hour, there will be a 50% chance of it emitting radiation and killing the cat. We shut the box for 1 hour and then open it. But the question is not if the cat will be alive once we open it. The question is if it will be alive immediately before, but there is no way of determining this answer since there is a 50% chance of either occurring. Therefore, the cat must be considered in a superposition of both dead and alive. Since it is impossible to tell which one it will be, quantum physics says both are true at the same time. Only when we open the box and measure the cat's state does it collapse into one of the two options. This same concept applies to everything in the universe. For example, if we don't measure the position of an electron, it will be in a superposition of every possible position in the universe. Therefore, it physically exists everywhere in the universe until we measure it, since only that act narrows its range of possible positions. The more accurately we measure position, the smaller that range will be. When we stop measuring the electron, it will once again exist everywhere in the universe until the next time we measure it. This causes perhaps the most unintuitive consequence of superposition. The entire universe is completely random. The strict laws of classical physics do not exist in the same way we know them to. Everything that happens is up to chance. If we measure the electron as between positions 0 and 0.1 meters, and with a velocity between 0 and 0.1 meters per second, when we stop measuring it, it returns to existing in every possible state, therefore having every possible position and velocity. So if we measure it again 1 second later, there is nothing stopping it from being between positions 2000 and 2000.1 meters, moving at velocities between 10 and 10.1 meters per second, even if it is affected by no forces. After returning to infinite possible states, it could collapse into any possible range of states, no matter what it was the last time we measured it. This is why the universe is random. Yet, classical laws are a very good approximation, and nothing on the scales we're used to seems to be completely random. For example, if you close your eyes while no one is watching you, you will be everywhere in the universe at once, since no one is measuring your position. That means that when you open your eyes again, you have a chance of ending up in the sun. Yet this has never happened before, so the chances must be astronomically small. To discover what prevents crazy probabilities like this from occurring, make sure to catch my next videos about wave-particle duality and quantum entanglement, as they will rewrite your entire understanding of physics. If you enjoyed this video, please give it a like. If you wish to further explore conceptual modern physics, subscribe to my channel and join me in the Physics Directive. Long live the Empire!